All right, I want to go through the back of the second page of our notes packet. We got through part of this in class, but not necessarily all, and I want to just go back through it. This is this packet that looks like this. Circles and tangents is what it says up in the corner. Second page, flip it over to the back, this is what you should see. Now, what this is all about is inscribed angles. And an inscribed angle is any angle that has its vertex on the circle. So like right here, this is an inscribed angle because its vertex is on the circle. So we're talking about this angle. And what I'm doing here, I'm highlighting this, but I'm also extending it past the sides of the circle because that can make it a little easier to see which angle you're dealing with. This is not as necessary on this one, but on some of the other ones it becomes more so. Excuse me. Okay, this is, we said an angle theorems on our angle theorem sheet. This was a central angle we had talked about yesterday. Central angles have the same measure as the arc they intercept. This is but today was inscribed angles. And inscribed angles, the relationship is the angle is half the intercepted arc. So if the angle is half the intercepted arc, then that tells me that 2x plus 1 is going to be half of 96. So that's the equation I'm going to write and solve in order to find this. So I have 2x plus 1 equals 1/2 96. If you would rather, you can also rewrite that as, or you can write that just instead, you can write it as, if this is half the arc, and I'm going to go ahead and highlight the arc the same color as the angle. Okay, if this angle is half of this arc, the other thing you could say is that this arc is twice as big as this angle. So in other words, I could say 96 is 2 times 2x plus 1. I can set it up either way and solve it. If I do it this way up here, half of 96 is 48, so I get 2x plus 1 equals 48. Subtract 1 from both sides, and I get 2x equals 47. Divide both sides by 2, and I get x is 23.5. So that would be my answer for number 13. On number 14, it says find the value of x. So I'm going to go ahead and highlight the angle that we're talking about for x. That has two sides here and here. It's like angle BDC. So if it's angle BDC, then the arc it intercepts is arc BC. The first letter and the last letter of the angle name tell me what arc is intercepted. So in order to find x, it's going to help me if I can find this arc out here. Okay, so I want to find that. Well, looking at what else I was given, I was told that this part of the circle is 110 degrees. And this part of the circle is 130 degrees. So 110 degrees and 130 degrees and the green arc together make up the entire circle. So if I want to find the green arc, I can subtract 110 and 130, which 110 and 130 add up to 240. So if I subtract 240 from the whole circle, which is 360. So 360 minus 240, that gives me 120. So if this is 110 and this is 130, this has to be 120 to make it all the way around the circle. And then I know the inscribed arc. That's what this is called, is the inscribed arc, the arc that's between the two sides of my angle. Here's my angle. Excuse me. The arc between the two sides is the inscribed, is the intercepted arc. Okay, so half of the intercepted arc is what I want. The intercepted arc is 120, so half of that is 60. So x is 60. Okay, moving on to the next one. The next circle has a triangle in it, and that triangle is an isosceles triangle. Let me remind you of a couple things about isosceles triangles here. If you have a triangle that has two sides the same length, in other words, it's an isosceles, those two sides are called the legs. The side that's not the same is called the base. And in every isosceles triangle, the base angles, the two angles on either end of the base, are going to be congruent. So in number 15, my two congruent sides are those two that have the markings. So that would be this side and this side. Those are legs. So that means this other side over here is the base. So that means that the two angles at either end of that have to be congruent. In other words, this angle and this angle. All of the angles inside a triangle have to add up to 180. So here I've got 70, and if I do 180 minus 70, that tells me I've got 110 degrees left for these two angles. If they're both the same, then I can take 110 degrees and divide by 2 to find out that each one of those is 55. Okay, the reason that's going to help me is x, this part out here, is the intercepted arc for this angle, the angle between the base of this isosceles triangle and between this side right here. Okay, this angle intercepts arc x, or the arc that's labeled with x. So if I know that this angle is 55, the angle, remember, is half the arc. So 55 equals 1/2 of x. And I'm going to write that as an equation real quick. Let me do this. 55 is 1/2 of x. The best way to get x alone here would be to multiply both sides by 2. Multiply by 2. That's 2 times. And 2 times 55 is 110. 2 times 1/2 is just 1. So x equals 110. So my arc x has a measure of 110 degrees. Juggling marker lids here. Okay, next one, number 16. Find the value of x. Well, let's look at what those angles have to do with. The angle that is marked 2x plus 13 has a side here, and it has another side here. Okay, so that means the intercepted arc for that angle is this part right here that goes between the two sides. Now looking at this other angle, the one that's marked 3x, it has a side here, and it has a side here. So the part of the circle that's between those two sides is also the same part. So basically what this means is you have two different angles that intercept the same arc. This angle cuts off that arc from the rest of the circle, and this angle also cuts off that arc for the rest of the circle. If they both intercept that arc, they have to be the same as each other. Let me give you a demonstration of why. Okay, if I have a circle, oops, and let's say that in my circle I have an arc of 100 degrees. Okay, if I draw an angle that intercepts that arc, that would be half of 100 degrees. And this is an inscribed angle. So half of 100 degrees is 50. If I draw a different inscribed angle that also intercepts that arc, it also has to be half of 100, so it also has to be 50. This is true no matter where I put it. I can put it anywhere on the circle. So, if anything that comes through that arc, the ends of the angle comes through that arc, that means it intercepts that arc, so it's going to be half of that arc, so they would all be the same as each other. So that's what we have going on in 16. The green angle intercepts this arc, and the sort of reddish angle intercepts the same arc. So they're the same. So I have 2x plus 13 equals 3x. So that's the equation I'm going to write. 2x plus 13 equals 3x. Collect my x's on one side. 13 equals x. And that's my answer. Now in number 17, this actually goes with the theorem. There's a theorem that says if you have a quadrilateral, remember quadrilateral is four-sided figure. So if you have a four-sided figure that is in a circle, inscribed in a circle, meaning the four vertices are on the circle, then automatically opposite angles have to add up to 180. Let me show you why. Okay, if I have a circle, and I could draw my quadrilateral any way I choose. Doesn't matter what kind of quadrilateral it is at all. It could be like a rhombus, it could be a parallelogram, it could be random. It could be no particular shape. But let's look at two opposite angles. Okay, like this angle and this angle. We're not saying they're the same, that's why I'm marking them differently. They're saying that they have to add up to 180. Here's why. The angle I marked in red looks like this. So the part of the circle that is intercepted by that angle is this part right here. So this angle is half of that part of the circle. However many degrees this part of the circle is, the angle would be half of it. This angle, the green one, goes through the same 2 points and intercepts the rest of the circle. So the green angle has to be half of this part of the circle. However many degrees this is, the green angle would have to be half of it. Altogether, the red part of the circle and the green part of the circle is the whole circle. And a whole circle is 360 degrees. So if the red angle and the green angle together have to be half of this whole thing, then they have to be half of 360 degrees. Because together they intercept the whole circle. So again, the rule is these two have to add up to 180. Let me give you a more concrete example. Let's say that this one is 100 degrees. Okay? Then this little angle right here is 50. All right, now if that's 100, then the green arc would be the rest of the circle. So 360 minus 100, which is 260. And half of 260 is 130. Well, 260 plus 100 equals 360. That's the whole circle. The arcs make the whole circle. So I wrote that so far down. And 130 plus 50 makes 180, half the circle. So, excuse me, anytime a quadrilateral is inscribed in a circle, like this one here, opposite angles have to add up to 180. So that means this one and this one, these two have to add up to 180 together. So together means I add them. 3x minus 18 plus 5x plus 12 all equals 180. So I'm going to collect my like terms. 3x and 5x is 8x. Negative 18 and 12 is negative 6 equals 180. Add 6 to both sides. 8x is 186. And x is 23.25. Okay, last one on this part. Looking at x, angle x, that's where it is. So the part of the circle I need to know in order to find it is this part right here. I already know this piece over here, the 50. Let's look at what else I know. What else I know is I know this 65. And this 65 is this angle. Okay, so that means this angle would be half of the intercepted arc. So all the way across here, from here across to here, is going to be 65 times 2, which is 130. Okay, this part is 50. If I do 130 minus 50, it's going to give me this arc right here. 130 minus 50 gives me 80. So this part right here is 80. And now I have the arc I need to find the green angle. I do half of 80 and I get 40. And that's my answer.